everyone. Today we are going to do a new chapter and we'll be starting machines that is there in our syllabus of class 10. Okay, so I'll start machine. Please keep your classwork copy ready in front of you while you are watching this video. Alright, and we'll start machine and we'll describe the different types of machines which are within our scope of the syllabus. And this chapter is very conceptual, as well as it requires a lot of practice in order to improve and in order to have a grip on this particular chapter. Okay, so now let's start. We'll start with machines and we'll complete levers today in this lesson, and in the next lesson we'll do the other parts of machines such as pulleys and etc. Alright, so keep your classwork ready. Let's start with machines. What is a machine? That is very important question. That what is the purpose of machine, that we actually have to learn this kind of chapter in physics. Actually, you see, we are surrounded by machines, and if you go back to the film of 3 Idiots, where this question was asked, what is a machine? So machine, technically, if I define, then it is a utility, a device which can reduce the human effort. This is somehow kind of concept, but the actual technical definition of machine suggests that these are certain blocks and systems. They are so connected that their relative motion is constrained. The relative motion among the system, among the blocks, among the parts of the machines, they are constrained. This is the definition that was given, that is written in the normal book. But up to our level of syllabus, whatever we have in our syllabus of class 10, we can just visualize a machine which reduces human effort. And with respect to machine, let me tell you, you should write down in your classwork that a machine means we have to understand two things very clearly. One is called the effort and one is called the load. The effort is the human, whatever effort is given, whatever effort is applied, and load is the section or the force which we actually overcome. I mean, we are applying effort in order to lift, in order to displace a particular amount of load that we have. So machine is a device where human gives an effort in order to get a certain amount of load to get lifted, displaced, or to get overcome. This is the basic thing. So let us now summarize. As you can see on the board, I have already listed the functions. What are the functions of machines? The first thing a machine does is it multiplies a force. That means suppose we have 10 Newton load and or 100 Newton load, okay, or maybe 1000 Newton load, means 100 kg of mass or something. So 1000 Newton of load when we have, but it is impossible for a person like us to just single-handedly we can lift the load and we can displace or something. Alright, so what we have to do is we have to think about a device, a machine, where we will apply a less amount of effort in order to overcome a large amount of load. So that's why we call it is a force multiplier. Even a machine can be a speed multiplier. Speed multiplier means we gain speed. Like we are pressing the accelerator of the car, where it is so smooth, we can just place our foot on it and then we can accelerate a car. We can gain a velocity of a car up to say 100 km per hour or something. Even a train in India which is running around at a speed of 140 km per hour, even more. So we use machine to increase the speed, so it can be a speed multiplier. Alright, you have a lot of examples in your textbook in the beginning. Please read those things, and so that you can understand it more precisely. And even don't forget that everything has a purpose. I mean, these kind of questions are asked in our school or board level exams. So we have to know. And the third thing is that changing the point of application, changing the point of application of effort. That means where we have to apply the effort, we are not able to. Now why we are not able to? Because that is not convenient to us. You see, human, excuse me, human always have tried to make everything convenient to them. Alright, we always think about a device or something which will be very convenient and easy to use. And there is a word called user friendly. So we are the user and we are thinking about the user so that it will be friendly. So we can change the application of effort. It's like you can take an example of a bicycle. Now what happens in a bicycle? You'll see that pedals, they are connected through a chain with this back wheel. Alright? And when we are applying the pedals just below our leg or where we are sitting or seat, and then we are applying the pedal, the force on the pedal, and then the chain is revolving and then the back wheel is rotating and then we are gaining motion. But we are not able to apply the effort to the back wheel, and because it is behind us, so it is not convenient to us. So that's why we are saying that changing the point of application of effort, and even the changing the direction of effort, changing the direction. You see, you have a bucket. When you are lifting it from the bottom, you are lifting like this, it gives you some kind of uncomfort. So what you do, we can apply a pulley system where we attach a string to the handle of the bucket and we can take it over the pulley, and then it is easier to pull like this. I mean, in order to live this way is not convenient to us, better to say. But when we are applying a pulley, we can just pull the rope and the bucket will come up. So that is also another thing we call the changing the direction. Previously we were doing like this, now we are doing like this. We are convenient to apply any force downward. Alright? So these are the functions of a machine that it serves to us to make everything convenient to us. And now we'll go to some terms related to machine where we can understand that how we can calculate different aspects through which we gain something out of a machine. Alright, so let's go for that. We'll start with mechanical advantage. So let us now try with the different technicalities associated with a machine. The first thing we should know is the mechanical advantage. You see, the physicists, they always thought about that what exactly we are doing. We are applying effort, we are lifting or displacing load, right? So they first thought about a concept called mechanical advantage. Right in your classwork, mechanical advantage, in short we call it MA, mechanical advantage. And what is the definition? Mechanical advantage is defined as the ratio of the load lifted with respect to the effort applied. You see, I am using two phrases, load lifted or displaced, effort applied, because I am applying the effort and we are displacing or lifting a load. So there is a ratio that how much load we are lifting or displacing and with respect to how much effort we are applying to the machine. And obviously both of these two terminologies, they are basically forces. So they do not have, they have the same unit. And obviously what we can say is that they do not, this mechanical advantage does not have any unit as per you can understand, it's a ratio. Alright, now we go to another concept called velocity ratio. Do write all this in your classwork. Velocity ratio, VR, in short we call it VR. And what is VR? It is the velocity of effort with respect to velocity of load. I was telling you previously that there is a concept, the function of a machine is also to gain speed. It is a speed multiplier, it is also a force multiplier. Okay, through machine we can gain speed, through machine we can gain the ability to lift a large load using a small effort. So velocity ratios tell us that what is the velocity of effort and what is the velocity of load. This is what we define as. But there is a bit of thing you can understand, we are deriving it. So velocity of effort is VE, velocity of load is VL, and velocity is displacement by time. So you are writing displacement of effort by time, displacement of load by time. So eventually time will get cancelled. So velocity ratio can also be defined as displacement of effort by displacement of load. Okay, so these are the two terminologies, and now we'll go to the third one, and this is very important. Already in the work power energy chapter I told you about this bit of this concept, but I didn't elaborate, but now we'll go for it, and that is called efficiency. Now efficiency is a concept where we can understand that it is denoted by the letter eta. It's kind of N with a long leg. Okay, eta is a Greek letter. So what is efficiency? We are applying load. We are applying effort, and we are lifting or displacing load. We have a velocity ratio. Everything is there. So there is a displacement of effort. There is a displacement of load. Everything is occurring. Okay, the machine is not a thing that will sit somewhere and perform everything. So it will have a displacement, it will have a motion, everything with respect to the point of contact or the point of application of effort, with respect to the point of load displaced, and everything will have a motion. So efficiency deliberately thinks that what is the total amount of work that we have given to the machine, and what is the total amount of work that we have got from the machine. Okay, so efficiency defined as that it is the work output, even you can say with respect to power also, that what is the total power we gain and what is the total power we expend when we have a expense of the power, and whatever power we are gaining. So that way also no issue. So work output to work input, this is the basic thing, and it is always represented with a percentage. So into 100 is there, because we always describe efficiency not as a fraction, we describe efficiency with a percentage. That helps us to visualize things more better. Anyways, so eta is work output. Now what is work done? Force into displacement. Force output force is load. So we can write load into displacement of load, and input is effort into displacement of effort. Okay, great. So this is you see, this is the definition. Now I am expanding the expression. So this is the factor. Great, good, no issue. So into 100 is there. Okay. Now in fraction, if I go just in fractional form, then what is eta? Eta is load by effort, definitely. And if I just extremely sorry, this will be DE. I'm sorry. Please rectify. This is DE. I just wrote DL. Anyways, because of the flow of thoughts. Anyways, so now we have a relation here. DE by DL is VR. So let us reverse this. So what I can do, we can just bring a division sign and we can just reverse the fraction. Okay, we are taking the reciprocal. So finally what I am getting load by effort is what? MA, and this is VR. So we have a relation eta equals to MA by VR. Of course, since eta is always designated with respect to percentage, so into 100 will be there, but in fraction we have derived this. This is a very important relation, and they ask you to show this relation in your school and board exam. It comes for 2 marks usually, but there you have to first define what is eta, and then you have to expand the expression, and finally you have to show these steps in order to prove that eta, efficiency, is equal to mechanical advantage by velocity ratio into 100, since we expressed eta or efficiency in terms of percentage, not in fraction. Alright, so these are the terminologies I am telling you, my dear students. These 3 definitions are very important in order to know the rest of the chapters. And I can understand, I hope you can understand that these definition or these terminologies are not that very difficult. So I hope you can easily have a grip on this. Alright, now we'll move into the next one, which is very important. This is a principle of machine and some terms related to that. Okay, let's check it out. So now we have understood the principle of machines. We have known what is MA, VR, efficiency, relations and everything. Now let me tell you one very interesting fact, that is the principle of machine. It says that ideally, quote unquote, that total output energy should be equal to total input energy. That means we always assume that an ideal machine is 100% efficient, but practically it is not. Now why it is not? This question usually comes, that why the machine is not ideal. Because of the reason, when we think about the ideal machine, we avoid few things. Now what are the things? First, we avoid the different bodies or parts which are connected in the machine as per the definition even. Those mechanisms, those parts, they have friction which we don't account. Okay. Second is, which is very important, that we don't account the motion within the machine, or when the effort or the load points they are shifting, and so the actual load on or actual effort or actual load or actual effort, they varies. Actually what is applied, it may change. So these are few factors in your textbook. It is clearly written 2 or 3 points. I will ask you to read those points, which are just simple learning. It's not very difficult. You can understand that a machine cannot be ideal. The real machine do not have an efficiency of 100%. It is much lesser than that. That you already know. We have done few problems in even work by energy, where we got the efficiency to be 40%, 70%, 60% and kind of. It never 100%. 100% efficient machines doesn't exist. Please count on this thing, that we haven't now till date couldn't actually manage to develop a machine which is 100% efficient. If that can happen, then that will be a miracle. Okay, so this is it. Now we'll move to the next topic. Just see what are the types of machines we have, and the first type we are going to do is lever. Okay, check it out. Levers. Levers is a special type of machines, and we can define levers in this way, that this is a kind of bar or an arrangement which can turn around a particular point. Okay, so we are again having the word turn. Understood? So turn we got in turning effect. We had a point of pivot, you remember? And now that point of pivot is here in levers. We call it fulcrum. Okay, Fulcrum. Fulcrum is denoted by the letter capital F from the first letter, obviously. So let us see what are levers basically. I told you the definition, write it down. Levers are a special arrangement or a bar kind of thing which can turn with respect to a certain point. So in all levers we can see some kind of turning effect. Okay, so let's check it out. We have this diagram. Please see the diagram, and you have to draw all of this in your class book. Okay, so types of levers. There are 3 specific types. We call it class 1, class 2 and class 3. Okay, don't say it in this way, that first class lever, second class lever or third class lever. Okay, it sounds very bad. It's class 1, class 2 and class 3, written in Roman usually. So the way I have written. So I have drawn a very schematic diagram of the levers. So you can see the class 1. What you can see here, we have a fulcrum which is in between the effort and the load. Okay, it can be anywhere. Okay, I have drawn it in mostly at the middle, but this fulcrum, where around which point the lever can rotate, since I told you it's having a turning effect, so that point can be anywhere between effort and load, and that's only we call it class 1. Very common example is beam balance, which is a class 1 lever. Even you can cite an example scissors. I'm going to examples. I'll come with that. But right now, this is the schematic diagram, the simple geometric representation of class 1. So effort is one side, load is at another extreme, and fulcrum is in between these 2 points anywhere. It should not be at the middle always. Okay. And then we have class 2. This is very interesting. In class 2 lever, the fulcrum is at one end and the effort is at the other end. Okay. And the load is in between the fulcrum and the effort. Here you can see the effort and loads, they are in the same direction. According to the principle of moment, we know that in order to stabilize the rotational effect, we should have the anti-clockwise moment equals to clockwise moment. So this effort will give this kind of rotation, this will give this kind of rotation, and then they will be balanced, and that's why both the directions are similar. But in class 2 and even in class 3, I'm coming to that, we can see the load and effort, they are different directions, because this will give a certain direction and that will give another direction. Since the fulcrum is at the other side, both of them should have the similar turning effect. This is having like this way, and this is like this. Okay, great. And in class 3, fulcrum is here the same way as of class 2, but the load is at the other extreme and effort is in between the fulcrum and the load. Okay, so now you have understood that how these 3 levers can be represented, how we can actually visualize this kind of levers, class 1, class 2 and class 3. Now let us go into the principle. Now what is the principle? Since it is having a turning effect, I'm telling you, this is having a concept of turning effect, and turning effect means we have one principle, and what is that? Yes, it is the principle of moment. Alright, so here what I can say about this is that principle of moment says that anti-clockwise moment total is equal to clockwise moment, and you can see there is only 2 forces. One is effort, one is load. So there will be 2 things. One is anti-clock and another is clockwise. So whatever it is. So what will be? I can say that load into the load arm. Okay, we say it is load arm. Now what is load arm? Load arm means it is the distance between, write it down, you can write it down. Load arm means it is the distance between the point of application of load from the point of fulcrum. Point of application of load and the point of fulcrum. That means this is the load arm, this is the load arm, and this is the load arm. Sure? Good. And similarly we have another thing called effort arm. We can understand the rest part is the effort arm. From effort till fulcrum, from the effort till fulcrum, effort till fulcrum is called effort arm. Okay, so load into load arm is equal to effort into effort arm. Okay, so this is the principle of moment. Turning effect is seized, restricted. In previously I was telling you, the machine is a combination of bodies or systems or blocks, so that they are connected in a way that their relative motion is constrained. Constrained means limited, restricted. So here also I am trying to restrict any motion. We do not want the machine to move. We want the load to move. We want the effort, application of effort to move. That's why we are telling this. We are restricting the machine from any kind of motion. You see, you have to understand that why we are having this kind of expression. Only mucking up won't help you. So, load into load arm equals to effort into effort arm. So, what is load by effort is equal to, you can say, effort arm by load arm. And eventually, by this time, you know, load by effort is MA, mechanical advantage. So you can write it is equal to effort arm by load arm. So we have got the expression of mechanical advantage for levers, generalized. Okay, this is a generalized expression. Now we individually see what happens. In class 1, you can see, I told you, in class 1, fulcrum can be anywhere. So anywhere means there are three cases. Now what are these? Either this low down and upper down can be equal if the fulcrum is at the middle, then the upper down and lower down are equal. So mechanical advantage is equal to 1. The common example is beam balance. I told you. Great. Then, if the fulcrum is more towards the effort, then the lower down is greater than the effort down. So what happens then? Mechanical advantage is less than 1. Okay. We usually prefer, is our general perception that whenever we are using a machine, then its mechanical advantage should be greater than 1, so that we can lift more load using a small effort. But it can happen that mechanical advantage is less than 1, even equal to 1. Equal to 1, I told you. Less than 1, yes, it can happen. I'm telling you what happens for less than 1. And if the fulcrum is towards the load side, then the effort arm is more than the load arm in class 1. So mechanical advantage is greater than 1. So in class 1 is a very peculiar thing, that it can have a mechanical advantage which is greater than or equal to or even less than 1. It can have all different cases. Okay. And since it has got all different cases, I will suggest you that you should categorize this class 1 lever into 3 parts: greater than 1, less than 1 and equal to 1, and write down the examples which are given in your textbook in these 3 columns, so that you can easily remember at the time of examination that what kind of class 1 lever is less than 1, having mechanical advantage less than 1 or equal to 1 or greater than 1. This will help you. Just take on a sheet of paper, write it down, make 3 columns: less than, equal, greater. Write all the less thans, all the equals. Equals are very less. Beam balance is a common example, and greater than 1 also are there. So use that. Like I'm telling you, one example: scissors. They are class 1 levers, because you'll see in scissors we have the pivot where it is riveted is in the middle. You hold at a point and you cut the papers or clothes or whatever from the other where the blade part is. So the fulcrum is in the middle, load at the other, your paper or cloth or whatever you are cutting, that is the load, and the 2 things, that is effort. So in scissors, usually the load arm is more than the effort arm, so mechanical advantage is less than 1. Now we go to pliers. Have you ever seen a plier? In electricians, they commonly say plus, but it is not a plus, it is pliers. But that is an example which is having a mechanical advantage more than 1. Why? Because you will see in pliers the effort arm is less. The effort arm is more. You will see the handle is bigger, and the section through which we hold it, a screw or something, when we open it or something, that is very small, but it is very heavy. It is made of good quality steel. Okay, so shears is another example which cuts metal. Okay, for metal, when we cut metals, we need more force, so we should have mechanical advantage greater than 1. Shear is another example where mechanical advantage is greater than 1. Scissors, I told you, with the mechanical advantage is less than 1. Beam balance equal to 1. Pliers greater than 1. So this way you have a lot of examples in your textbook. Just categorize in 3 columns: less than, equal and greater than. Okay, so this is your job, you have to do, and I will definitely want to see it in our WhatsApp, AccentUs WhatsApp group. Okay, now come to the class 2. What you can see, that effort arm is always greater than the load arm. You can see it here as per the arrangement of class 2. So here what you can say, that MA for this kind of lever is always greater than 1. Always greater than 1. You have a lot of examples for class 2 levers. You can have a look in your textbook. I am coming to that for the examples. And for the class 3, we have, you can see, the load arm is greater than effort arm, and it is always. So it is having a mechanical advantage which is always less than 1. Okay, so why we are using a lever or a machine which is having a mechanical advantage less than 1? Because of one thing, in the beginning I told you, the function of a machine is not to have a mechanical advantage greater than 1. We may require a device which can gain speed, a bicycle. The amount of effort we give and the amount of kilometers we can travel, if we compare, then we can see that when after cycling we get drenched, we get a lot of sweats because we had to give a lot of efforts and we overcome very less amount of load. It is having a mechanical advantage less than 1, but it is used. Why it is used? Because the pedal system, whatever rotation of our legs or our feet, whatever we are doing, as compared to the amount of displacement with respect to our effort and the amount of displacement of the total load, which is much higher, because you can see the load arm is greater. So what happens? We can cover a large distance. Our intention was to gain speed. Maybe we are applying more effort than the load, but our intention was to gain speed. Even for scissors in class 1, which is not class 3, scissors, we gain speed. We want to cut papers or clothes fast. Alright, so these are the common examples. Even there is another example for class 3, which is knives, any knife, I mean in the kitchen or soldier's knife or whatever. But what happens, since we have longer load arm, so we can keep ourselves away from the things to cut or something, so that we doesn't hamper us. Accidents don't occur. It is always applicable to the load and it is far. Okay, suppose take an examples like in nuclear power plants when they pour the uraniums. Okay, so do you expect the humans or a machine to have those explosives or those kind of radioactive substances to be very close to us? No, obviously not. So we keep them away. So we use a class 3. Okay, so now since we already know all these things, we have a few sums. I'll do that later. Now let us see. I'll explain you about these 3 different types of levers and their examples using few pictures that will come up now. These are examples of class 1 lever. You can see in the diagram. As I told you, you should categorize these examples into 3 segments, that is mechanical advantage less than 1 or equal to 1 or greater than 1. You should do that. Okay, these are the examples. Again, I'm repeating for class 1 lever. This is class 2 lever. In this case, the mechanical advantage is always greater than 1. You can find more examples in your textbook. Go through that and find out other examples. And this is very important because they can ask you questions about different types of levers. And obviously this is class 3. Here mechanical advantage is always less than 1, and class 3 levers are speed multiplier, unlike class 2 which are force multiplier. And you already know by this time that class 1 levers can be force multiplier, speed multiplier, or even they can have a mechanical advantage which is equal to 1. This is showing you the presence of class 3 type of lever in our human body. This is you can see lifting a load using our arms and muscles, and efforts and loads and fulcrums are mentioned in the diagram. Okay, these you can also find in your textbook. This is a better representation of the diagrams you have in your textbooks. This is class 3 mechanical advantage less than 1. Again, another examples of human movement where the concept of levers are applicable. This is class 1. So any nodding of heads, it's class 1 type of lever. Please copy this problem in your classwork. We'll solve this problem now. So you have seen the problem and even written down that problem in your classwork. There was a diagram which was indicating a well barrel, and the problem is a bit tricky, but we'll solve. First, I have arranged the informations they have given to us. What are the information they have given? First of all, they have given us the information that the total load arm they have mentioned, you can see in the diagram, is 20 centimeter, and the effort I am applying at the end. So the distance from from load to the end was 40. So adding 40 and 20, the total effort arm where we are applying effort at the end is 60 centimeter. It is not 40. I have seen that lot of my students, previous students, I gave this sum to their exam, and they did this wrong. I mean, they took the effort arm to be 40, but it is not 40, because you have seen the fulcrum is at the extreme. Okay, and again there is another mistake that you usually do. What is the total load I am lifting? They have said that the machine itself is having a weight of 15 kg, and then you have given a load of 30 kg. So since they have mentioned the load is 30, so we usually think, okay, then the total load is 30, but no, it is having a weight, so that is also have to be registered. We have to write that. So we have to add and find out the final total load we are lifting is 45 kg, and it is not 30 kg. Please be careful. Okay. So now they have asked these two. They were asked, so we have already solved. Now our next part is we have to calculate the mechanical advantage and the amount of effort required. So first, let us calculate the mechanical advantage. This is part 3. So MA, you know what? MA is effort arm by load arm. This is from the principle of moment. We derived that previously, just few minutes back. So you can understand it is 60 by 20, and that is equal to 3. I have checked so many copies, my dear students. You can't imagine, in last 23 years I have checked so many copies where this sum they got an answer of 2, mechanical advantage, taking the effort down to be 40 centimeter instead of 60, and the rest of the part. So you get only these two will carry 1 mark. You will get that. The rest is wrong, because once your mechanical advantage is wrong, your effort will be wrong again. Okay, so this is the answer. And the last part, they have asked for the effort. So obviously MA can also be written as load by effort. So now you can easily understand effort is equal to load by 3, which is 45 by 3, mechanical advantage, which is 15 kg. You see, once you have understood the thing, it takes few seconds to complete. Otherwise, you can spend a year, but you won't be getting the answer, I mean the right answer. Okay, so this is the thing. Alright, I'll do another sum, problem 2. Now we have a crowbar, and they have said the total length of a crowbar is 1.5 meter, and the load it is lifting is 75 kg with a certain amount of effort applied. And they have also said that the distance between the effort hand and the fulcrum, I mean we have to fix the crowbar at a certain point, and then we can do that. So that turning is fulcrum, and that length is 1 meter. They have asked mainly, you can understand, they will ask 3 things. First, they have asked what is the effort arm, what is the load arm, what is the effort, and what is the MA. Okay, so these few things we have to understand, we have to calculate. So first, let us do effort arm. Effort arm is already given in the sum, that is 1 meter. They didn't ask effort arm, they asked for the load arm. So obviously the total length is 1.5 meter, so you can understand that load arm is 0.5 meter, just 1.5 minus 1. Okay, next is they have asked for the MA. So MA, I think now you can even have calculated by this time before I am doing, because you are faster than me. Alright, so the mechanical advantage is effort arm by load arm. So effort arm is 1, and the load arm is 0.5, so you can understand it is equal to 2. Okay, great. And the last part is the amount of effort. So obviously amount of effort is again mechanical advantage is 2, the load is 75, and effort I don't know, and now I know it is 37.5 kgf. You see, it's so simple. Okay, so this way I have concluded the first part of machine, which is levers and the principle of machine and different definitions with respect to machine. This we have now completed, and we have done few sums. Now it's your part. What you have to do, you have to sit back with your textbook and with the class book that you have written today, and then you will see all the examples. Even I told you to do a classification of class 1 lever into 3 parts, 3 columns: MA1, MA less than 1, MA greater than 1. That is also your task, and you have to do that. And even you have to classify the different examples of class 1, class 2 and class 3 levers, even for the given bodies that I already told you before. And then you will do all the solved examples in your homework copy, as well as the complete exercise that is there after this section, including numericals. You'll complete everything and show me, and then we'll come up with a doubt clearing session in our AccentUs WhatsApp group. Alright, we are going through a very bad situation. Hopefully, I don't know when this is going to get over, but I want to see you very soon. I want to see you in my class, sitting in front of me, and definitely I hope that is not very far. I'm really missing you all in my classes. Anyways, and I'm telling you, again I'm telling you, you might find that you're not going to school, you're feeling bored or something, but I'm telling you, since this is your board year, you have getting more amount of time, so you can actually spend those time to improve yourself. So I'm telling you again, stay safe and stay productive. Okay, so this is it for the today's class. Okay, and we'll come up with the next lesson with pulleys and other things in machine. All right, until then, bye bye. And again I'm telling you, stay safe and stay productive.